Right. So our next topic is Taylor series. Okay. So this is most fundamental for entire Newtonian mechanics. So whatever we study in Newtonian mechanics mostly linked with this. So any physical quantity or any function can be expanded as a power series. Is the title of the story. Power series expansion. So let's say you're given some function, so that can be expanded around a point. Let's say this is f of x0, f dash x0 into x minus x0 by 1 factorial. All other higher order derivatives. So the function continues.
N factor.
Like that. Okay. So the basic issue is you are expanding any function, if possible, as a power series. So what is the purpose of this and how does it work is a matter of discussion. So let's say we are considering, let's say, take some function. Let's say you have given a curve, a graph like that, a curve, and we need to get the function form for that. We know some functions already, like let's say this is x is equal to constant. Sorry, y is equal to constant. Okay, and another function, let's say y is equal to x. Another function y is equal to x square. X cube. Okay, we have a set of functions like this. X power 4, almost similar to x square but little steeper. Okay, so these are a set of functions that we see as a graph. Now, what combination of these functions will give you this kind of graph, this kind of curve? Let's say this graph is starting not from 0, so this may have contribution from here. It is rising linearly, some contribution from there, and maybe let's say x cube minus x square or x square minus x cube. Maybe, I mean, if you subtract this, how do you do that? X square minus x cube.
Values.
So you have to flip the curve. This is minus x cube and this is x square. If you add both of them, what do you get? This is, some of these two will be more steeper, and here a positive number and a negative number. Negative is rising quick. So some combination. So like that, if you take all the combinations of these x square, x cube and all these functions, you may arrive at some functional form for this curve. Right? So the basic idea here is to get the function form for any curve or for any graph, we should know the value of the function at origin, let's say whatever.
సార్ ఒక నిమిషం అమ్మాయి నాకు ఇక్కడ మన టీంలో పిఎం
Right. So all we have to know here is the value of the function at a particular point. Let's say this is origin. X0 is, let's say if it is assumed as origin, then we should know the value of the function at that point and slope of the function. Let's say f dash is the slope df by dx. Second derivative, third derivative, all derivatives of the function at that particular point. If that is known, we can predict the final form of the function. So let's say you have this curve. What is the function form of that? Let's say this is x square plus 2. Okay, so like that, let's say this is shifting. I mean, x value itself is shifting. Let's say the curve is like this. What is that? Is then x minus 1 whole square plus 2. X minus 1 or x plus 1, some functional form. Okay, so like that, if you know the value of the derivatives of the function at a particular point, you can predict its future course of action. Which way it will move can be predicted, right? So that is the fundamental idea in this power series expansion. I mean, you don't need to know about the function form. I mean, we'll go through an example. We don't need to go through, I mean, we don't need to know the functional form. All we need to know is the derivatives of the function at a particular point. Right? So the value of the function at a particular point and all its derivatives at that point. If that information is supplied, we can predict the future direction of motion of the curve. Okay. So let's say, for example, I'm taking e power x and my origin is 0. Okay, so now what is the form of the function? F of x at 0. One. F dash of x. Derivative of it is e power x. At x equal to 0. F double dash f. So all the derivatives are 1 at that point, at origin. So now the total function becomes what? So f of x is equal to 1 plus x0 is 0, f dash x0 is 1, so x by 1 factorial, x square by 2 factorial, is x cube by 3 factorial, like that. So, I mean, if you substitute these values, you'll get value of e power x. So, what information are you supplying to arrive at this functional form, to arrive at that power series? What are the inputs? Only these numbers. I mean, I don't even know the functional form actually. If somebody supplies me this number, just the number, Since I know the function, I'm just confirming it that the slope is 1. But even without knowing the functional form, if just the slope information is supplied, I can arrive at the power series for the given function. Okay, like that you can, let's say f of x is sin x. So then f dash x is cos x at 0. Cos 0 is 1. Then f double dash x minus sin x 0. F triple dash x minus cos x minus 1. So alternatively you will get plus 1 and minus 1. And first number is 1. So f of x at 0 is 0. So we will be left with 0 plus x by 1 factorial minus 0 minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, like that. You get sine series. Okay, you can try any other functions like cosine x, tan x. Any function can be expanded as a power series. Okay, so this is the basic idea, and we are going to use these derivatives at various, like your harmonic oscillator, waves and oscillations. All these problems will involve these derivatives of a function, especially if force. Okay, so further we'll see about slope. So is this clear? Like any function, if you know the value of the function and its derivatives at a particular point, only at a particular point, that information can be used to generate entire curve. So if the derivative includes x cube kind of term, x square kind of term, then we can predict which way it will move. Okay, so now our next topic is slopes. So that this Taylor series, Leibniz series and all are developed parallel to Newtonian mechanics actually, and their origins were found to be in India, Kerala. So it is Madhava series. It was introduced by Madhava, and further it was renamed as Madhava Leibniz series. Okay, so all these power series expansion of the functions were developed in India actually. Now we'll see what is the derivative of a function. So derivative information is also mandatory to know to analyze these mechanics problems. Okay, so derivative deals with, let's say, what do you mean by derivative? Derivative అంటే ఏంటండి ఇంతకీ? Differentiation, rate of change గురించి మాట్లాడుతుంది. Okay, So let's say an object is moving with constant velocity. V is equal to 1 meter per second. What happens to its displacement? As a function of time, if you draw the displacement curve, right? If the object moves with constant speed, what happens? For each unit of time, it travels equal distance. Okay. So now, what is the velocity? Velocity is rate of change of displacement. There are so many definitions for that. One is ds by dt, where you will take 2 points another is instantaneous velocity. What is instantaneous velocity? At a particular point. At a particular point of time, just grab the information about position and time. Okay. So at a particular point, if you define that, you'll get instantaneous velocity. And if you subtract two of them, like s2 minus s1 by t2 minus t1, so this is the difference of the velocities. So if you take 2 points like s1, t1, and at a time t2, s2, difference of those two, s2 minus s1 by t2 minus t1, will give you velocity information. Let's say somehow there is a bump in the graph. So at a particular point of time, the object is moving quickly, so the displacement increases quickly, and it slows down after that. Two vehicles are starting at the same time from the same point. One is traveling like that. As a function of time, displacement is increasing uniformly. And another one raised its speed and then reduced, managed to travel along with the first one. So now, in this graph, if you use this formula, what do you get? The value of the velocity depends upon the points you choose. If you choose these same 2 points, you might get the same number as the first one. But in between, at some point of time, the velocity is changed. So you may not grab that information when you take a long interval. So the best option is you have to reduce the time interval to 0. That gives you the best information about velocity. And okay, so how to define that? You have to take a very small interval. So there are two derivatives. Let's say at a particular point, f dash x is given by f of x plus h minus f of x by x plus h minus x. So let's say for any curve, you're taking x and x plus h, a small interval. So this is called left derivative, sorry, right derivative. It's called right derivative. So you're calculating the derivative by taking the interval to the left of the initial point. Sorry, right of the initial point. It's called the right derivative. Okay. I can also define the derivative from left side. So f dash x also can be defined from the left side as f of x minus f of x minus h by x minus h. This is called left derivative. Right? These are the two definitions for defining derivative. One is on the right side, another is on the left side. At some point of time, especially when you come across quantum mechanics, the curve is whatever wave function is said to be continuous. Then only we'll be able to define certain quantities in quantum mechanics. So the definition of continuity is this left derivative must be equal to right derivative. So let's say you're given a function with a sharp change in the slope. So if you measure the slope at this point, so first of all we'll see different forms of slope. Let's say the curve is parallel to x-axis. The given function is parallel to x-axis. Okay. What is the slope? Slope ఎట్లా calculate చేయాలండి? But you take 2 points. x1, x2, y1, y2. Both y1, y2 fall at the same location. So what is the slope? See, and if it rises up, then so y2 minus y1 by x2 minus x1 will get a positive number. It is positive slope. So next, if it is a falling curve, what is the slope? x1 y1 x2 y2. So y2 minus y1 by x2 minus x1. So y2 minus y1 is negative, x2 minus x1 is positive. Overall slope is negative. And what if it is along y-axis? Infinity. So here both x1 and x2 fall at the same point, y1 and y2, let's say. So here slope is infinity. So if the given curve is parallel to x-axis, slope is 0. If it rises up, slope is positive. If the curve falls down, slope is negative. If it is parallel to y-axis, slope is infinity. Okay, so these are the different possibilities for slope. So now, a curve is said to be continuous if left derivative is equal to right derivative. Okay, that means what? Let's say at any point, at some point, calculate the left derivative. What is the left derivative? On the left side of that point, the curve is rising up. So here the slope is positive. On the other side, is negative. Right? So then what is the situation? So left derivative is not equal to right derivative. So these kind of functions are not continuous. So at any point on the curve, however small the interval you consider, if left derivative is equal to right derivative, then the function is said to be continuous. I mean smooth. Okay. So next we have to look for maxima and minima. You might have come across that. Maxima, minima ఏం చేస్తుంటారంటే ప్రాబ్లమ్స్ ఎక్కడైనా ఉన్నారా? How to find maximum of a function and minimum of a function? We'll be using derivatives. First derivative, second derivative. Maxima is a point, or maxima or minima is obtained by making the first derivative equal to 0. And sign of the second derivative decides whether it is maxima or minima. So it's a small example related to maxima and minima. So I'm taking some function sin x, let's say. Okay, so this function is starting from 0, rising, and this is the maximum value, and after that the function value reduces to 0 again, and the function value reduces to negative side, and this is the negative maximum or minimum in the function, and finally it goes to 0 again. Okay. Now what is its derivative? Means derivative means what? Slope of that curve. I have to draw the slope of that curve. I have to check whether the function is rising or falling, or whether it is parallel to x-axis or perpendicular to x-axis. All these things we need to confirm. Right? So initially the function is rising, and at this point slope is 0. At that point the function is parallel to x-axis. So at that point slope is 0, and let's say from some maximum value the function is the slope of the function is falling to 0. Right? So by the time you reach here, you have to start from some maximum value and approach 0. And here what? Slope is on the negative side. This is negative slope, this is positive slope. So from 0 the slope is increasing to a maximum number on the negative side. This is a falling curve, and that too it is increasing sharply. From 0 it is approaching to a maximum number. So that is the slope. And next one, here the slope is positive or negative? In this portion slope is negative and is approaching 0. So negative value is approaching 0. So the curve looks like that. And if you continue that, from this point onwards, from zero slope, it is increasing to a maximum number. So that is the slope information. So let's say if you call this as f of x, this is f dash x. And fortunate or unfortunate, this function is cosine x. Okay. So this is the first derivative. And if I take the second derivative, I have to calculate the slope of this curve. So how is it varying? Here the slope is 0. Slope is 0. Function is maximum, but slope is 0. And the value is increasing to a maximum. Positive or negative? Slope. Slope is negative. If the slope is negative, starting from 0, it is going to a negative maximum. So this is the type of curve we get. And here still it is negative, but it is approaching to 0. So at this point, this is the graphic. So from this point onwards, slope is positive. It is starting from 0 and approaching to a maximum number. So f double dash x is minus sin x. Okay. So now, let's say this is the given function. Where is maxima and where is minima? Here at 90 degrees, let's say. This is not degrees, so whatever. At this point, you got a maxima, and at 270 degrees location, you got a minimum. And how to identify that? So if you see the first derivative of the function, wherever the first derivative becomes 0, the function will have either maxima or minima. Because that is the point where the function takes a turn. On one side of that point, you'll have positive derivative, and on the other side, you'll have negative derivative. So in between positive and negative, you get a 0 derivative. Okay, so that is a turning point for the curve. So that's called a turning point. That may be a positive peak or a negative peak. Whatever may be the situation, when the slope of the function becomes 0, you'll get either maxima or minima. Right? And if you see the second derivative, sign of the second derivative, if the second derivative sign is negative, the original function will have a maximum. If the sign of the second derivative is positive, if the sign of the second derivative is positive, you will get a minimum. So that is how we consider. So maxima is the location where slope is 0 and second derivative negative. Minima is the location where slope is 0 and second derivative positive. So this is the basic idea we use in some mathematical calculations. Okay. Right. So the first condition for this Taylor series expansion is function must be differentiable. I mean, even if the derivatives are 0 or any number, the function must be differentiable. I mean, the derivatives must exist. Otherwise, you cannot expand the given function Taylor series. That is the first one. So, with that introduction, we will go into simple harmonic motion. Simple harmonic motion. Simple harmonic motion. So to explain this, we are considering Taylor series expansion for force. So I'm taking Taylor series expansion for force, and I'm imposing conditions. One is f of x0 is 0 and all higher order derivatives are 0. F double dash x0, f triple dash x0, all are 0, and first derivative is a negative constant. So these are the conditions I am imposing on the force. So here force at the origin is 0, all higher order force terms are 0, only first derivative force is a negative constant. It is not positive, it is a negative constant. So all these conditions lead to a peculiar kind of motion, and that's called a simple harmonic motion. Okay, we'll see what does it mean. And I'm considering origin is 0. Origin is at 0. So these are the conditions. So now what happens? F of x is equal to minus k x. I'll be left with that. So what is the meaning of that? Force is increasing as the displacement increases in an opposite direction. So let's say an object is sitting at the origin, and you try to displace the object from the origin. When you try to displace the object, there arises a force opposite to the displacement. If the displacement is along positive x direction, force will be along negative x. So displacement is opposite to the direction of motion, and this force is proportional to displacement. That means what? More the displacement, more is the force. So at this point, force is 0. At the origin, force is 0. This is smaller. Let's say 1 unit, 2 units. So as the displacement increases, force increases. So more the displacement, more is the force towards the origin. So what happens? Let's say you are displaced it to a certain length and you have released the object. What happens? The force will push the object to the other end. Okay, so when there is a force, there is a acceleration. Okay, so the object moves, its velocity increases, keeps on increasing up to this point, and at this point force is 0. So acceleration is 0. That means what? Momentum is constant. So then Newton's first law applies. When there is no force, object continues to be in the state of rest or uniform motion. So here if the momentum is 0, it continues to be at that 0 momentum. But since there is a finite value for momentum at this point at the origin, the object continues with that momentum to the other end. How far will it go? There is a restoring force always acting. So it continues to a distance where whatever energy it has is sufficient to balance with the restoring force. So as long as it continues to move to the other end, restoring force will be pulling it back. So some brakes are being applied. Brakes apply అవుతున్నాయి ఎక్కడ ఆగుతుందండి wherever that braking force is equal to your existing energy. So when that balances, the object stops at that end. And again, because of the restoring force, it comes back. So the process continues. So here because of this constant, what is happening? The force is increasing continuously as you go away and away from the horizon. The force is increasing constantly as you go away and away from the horizon. What else? So it is a restoring force. So the object traces back its original path. The force is opposite to the direction of motion. So object traces back its original path. So conclusion, this force is called cyclic force, or what do you call that? Conservative force. So whatever energy lost in the process of displacement from the origin will be gained back when it comes towards the origin. So net energy conserves. So the net force over a complete cycle will be 0. If you take force over a complete loop, it becomes 0. Integral f dot dl is 0. So we can write, in this case, we can write this force as a negative gradient of some potential. Only when the line integral becomes 0, you can write the force as negative gradient of some function, potential. ఎందుకనండి? I mean, negative is a matter of discussion, but you can write it as a gradient of a function. So what does that mean? So దాని అర్థం ఏంటో ఒకసారి చూడాలి. So f dot dl is 0 implies this can be written as a cross product of function, gradient, sorry, del cross f becomes 0. So the value of the function over a complete loop is 0 can be written mathematically as del cross f is equal to 0. So del cross f 0 indi ante we can write it as f can be written as del cross del dot of something. Cross product and dot product of same function will become 0. So if cross product of some function becomes 0, that function can be expressed as dot product of another function. Okay, so that that cross and dot product will result in 0. So in this case, when the force over a complete cycle becomes 0, that function can be expressed as a gradient of some function. I call it as potential, and here in this case it is a negative gradient. So what does that mean? Only when the potential difference f is equal to minus of v2 minus v1. At two locations in space by h2 minus h1. So force is positive when the potential difference is negative. So force is positive when potential difference is negative. Then అర్థం ఏంటంటే, let's say you are taking 2 points 1 and 2. So if the force is positive, the potential difference is negative. The force is along the direction where potential difference is negative. Potential difference negative అంటే ఏంటి అర్థం? V2 is smaller. The force is directed along the direction of falling potential. So force is directed from high potential to low potential. Okay. So this is the origin of force. So when there is a potential difference, then only force exists. So if any 2 points in space have same potential, force will be 0. If there is a potential difference, force will be from high potential to low potential. Let's say even in waterfalls, the directive force will be from high altitude to low altitude. Okay, so that is the fundamental thing that you have to understand at this point. The force is directed from high potential to low potential. So it is directed towards negative gradient of potential. Okay, so ఇక్కడ ఏం జరుగుతుందండి ఓవరాల్ గా? So it is a conservative force. Whatever force acting on this system is conservative force. So if you solve this differential equation, what is the differential equation? F is equal to minus kx. So d square x by m d square x by dt square is equal to minus kx. So if I take it to the other end, d square x by dx square is minus k by m x, or d square x by dt square plus k by m x is equal to 0. Okay, so what are the units of this function k by m? K by m units ఏంటంటే, k is force per unit length. By mass. So if you check the dimensional formula, force is mass into acceleration. So m L t power minus 2 by L by m. Mass into acceleration, m L t power minus 2. So you'll be left with t power minus 2. So inverse square of time. So you can write it as d square x by dt square plus omega square x is equal to 0. Inverse square of time, where omega is 2 pi by t. So I'm introducing a factor of 2 pi by hand. That part we'll see later. But the solution of that equation is what? So if we solve the equation, you get either sine kx minus omega t or cos kx minus omega t. Since there is no it's only time derivative, you'll have sin omega t is a solution or cos omega t as a solution. Okay. So this is the differential equation for simple harmonic motion, where the force is a conservative force. So whatever energy lost during the displacement from origin will be gained back when it approaches the origin. There is no loss of energy. Okay, only in that condition we can write it as we can write the force as a negative gradient of potential. So then how to get that potential? V is equal to minus integral f dot dx. F dot dx. So what is that? F is equal to minus kx dx. So it is half kh square. The potential looks like a parabola. So this is the potential energy gained by the object. This is the displacement. So what does that mean? At the origin, the energy of the object, potential energy of the object is 0. So as you move away and away from the origin, the potential energy of the object rises. So however far you travel, you will gain more and more potential energy. So this is a graph of energy gained by the object during this displacement. So as you pull the object more and more, its potential energy increases. So that is the energy graph.